So in last session, we discussed about how to uh, define different constraints like default and check, primary key, not null, and unique key. And also we discussed about how to alter the table for adding a new column to the existing one, and for dropping a column from the existing table, and for altering the data type of the column. Remember one point, whenever you are changing the data type of the column, for example, the employee name data type is varchar of 100, the current one. And if you want to change it to integer, you cannot change it if you have any records present in that particular column of, it should be of data type integer, then only you can change, or else you cannot change it. But, let me take an Excel. Or let me take this select statement. If you see this column data type, this has data like Rupesh and Rupesh in 2 rows. I cannot change this one to integer. Why? Because whenever I change this data type to integer by using alter table query, here I am showing, right, using this, then it will try to change the data that is present in the table. So which is not possible, and hence it will throw error saying that the data should be cleaned up first. So you have to make sure whenever you are changing the data type of any column, then you have to make sure that the data present in the column is compatible to the new data type that you are going to provide. So this is one key thing you have to remember. In today's session, we are going to discuss about a couple of things. First thing is, let's start with the foreign key. This is also one type of constraint. I missed it in last session. And we're going to discuss about group by and having class, and also couple of functions. Okay, let's start with foreign key. So this is also one type of constraint. Till now we discussed about 5 constraints: primary key, unique key, not null, and check, and the other one is default. All these constraints can be applied on any one column or couple of columns of the same table. Okay, in any table you can apply this, but this foreign key, this relates two tables. This one will make sure, let me show you an example by taking the Excel. Let's say I have two tables. The first table name is employee and the second table name is leaves, which I have taken earlier. So here I am taking employee ID and name, and then let's say designation. I have 3 columns in this first table. Here leave ID, and from to is approved. Let me spell it properly. Is approved, and approved by, and again employee ID. So to have relationship between these two tables, I explained this part when we discussed about master and transaction tables. Now here if you see, this column is related to this column. These two columns are related, and using these two columns we will apply joins on these two tables. We discussed about all the joins, and while discussing about the joins we had a look at master table and the transaction table. Now this foreign key relationship is set between two similar columns of two different tables. Let's say this is your master table. Okay, this is your master table up to here. This part is master table, and this is your transaction table. So if I define foreign key for this employee ID in the transaction table by referring it to the employee ID of the master table, then what it is gonna make sure? That is what we're gonna discuss now. So if I define a foreign key, what it will make sure is no orphan records. This is the first point it is gonna make sure, and not allow it will not allow to delete parent record without deleting child record. Okay, these are the two things what it will make sure, the foreign key relationship. And before going to the syntax of foreign key, let's discuss about these 2 points, that is no orphan records and it will not allow to delete parent record without deleting child record. So what is meant by orphan records here? The first thing. So let's say I'm entering, this is the employee ID, this is the employee name, designation is PL, let's assume. And leave ID is 1, from date is some blah blah blah, I'll give some blah 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 date to some blah 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 date, and is approved is S, approved by some manager, let's say Venki, and employee ID is 1. So if you observe, this employee ID is there in the master record, master table, and I am using the same in the child table. If I insert one more employee leave details, and if I take employee ID as 2, the guy, this 2 is not present in the master table. Okay, this is parent table, this is child table. And if I use any ID which is not available in the master table, parent table, then this key is called as orphan. So this guy does not have parent here. So the first thing the foreign key will make sure is it won't allow me to insert the data with any ID which is not available in the master. So this is one good thing. This is one good way to maintain proper data. Why? Because without having an employee, let's take this case. If I tell to any guy, any person who is auditing the business, if I say there is a leave taken by an employee ID 2, okay, and if the audit person asks me who is that employee ID 2, and if I say there is no ID for employee ID 2, so I don't know, that is not the proper answer. That is not the proper way to maintain the record. So these kind of orphan records will not be entertained by foreign key relationship. And the next thing, so this is not possible. I mean, adding the employee ID 2 is not possible. And the second thing, it will not allow to delete parent record without deleting children record. So what that means is, let's say I have an employee ID 1 and he has taken a leave. If I try to delete this record, and if I deleted this record, then this one will become orphan. So what foreign key will do is, foreign key will make sure that this parent record will not be deleted until you delete all the child records with the same ID. For example, if I want to delete the employee ID 1, the record with employee ID 1 from the parent table, then if I have 4 records like this, where I'm using employee ID 1, which I want to delete from the parent table, in that case, first I have to delete all the records from the child table, then only I can delete the parent record. Not all the records. Don't think otherwise. If I have ID 2 here, and I have an employee with the name Venki, project manager, in this case, if I want to delete this guy, employee ID 1, if I delete these 4 records will become orphan records. So what foreign key will make sure is, it will say first delete these child records, then only I will allow you to delete the master record, that is parent record. So this is the advantage of foreign key relationship. Foreign key always make sure that there will be no orphan records. In this case, if you see, if I allow to delete this, the result is these guys will become orphan. Sorry, these guys will become orphan. So it is making sure that no orphan records will be available. And if I try to enter a record with employee ID 3, this one will become orphan and hence it will not allow. So what it will do is, what it will say is, first go and add an employee ID 3 here and then come to the child table to take the leave with the employee ID 3 in this case. And let's say he is DL. then only this one will be allowed, or else it will throw error. This is how the foreign key will make sure. Um, these are the things what the foreign key will make sure whenever you try to insert a record. No orphan records and no deletion in the parent table, which will lead to orphan records in the child table. So now let's see how to implement the foreign key. As I told you, foreign key will be applied on two tables, not on one table. Okay. Very typical cases, very rare cases, you can apply the foreign key on the same table, which we call it as parent-child hierarchy. We'll discuss about it later when we discuss about SSA sessions. Now, to demonstrate the same, I'm creating two tables. Create table. Let's say I'm naming it as employee. I'm not going to have more columns. Employee ID, integer, primary key. Next one, employee name, varchar of 50. So this is one table, and the other table is create table leave details. I will make it short. I'm giving leaves. So leaves, I'm defining these three columns. Leave ID, I'll make it as integer, and number of days. I'm not maintaining the to and from and all those stuff. I'm giving simply number of days. This is integer, and who is the employee that applied. The column may be of different names. It should not be the same as the column here. Column name here. It is employee EMP underscore ID. Here I'm giving EMP ID, but the data type should be same. The data type. Now, this is your parent table and this is your child table or transaction table. Here we have to give this foreign key reference. Foreign key references. What it is going to refer? It is going to refer to the primary key column of the employee table. So here I have to give what is the table name and what is the column name. So this is how you have to define the declare foreign key on a transaction table. So the meaning of this one is, this is one table. This is plain table, just like other tables what we created with the two columns. One is employee ID and another one is employee name. And this is the transaction table or child table where we have leave ID, number of days, and employee ID. This employee ID is referring to this guy, the parent table employee ID. So employee ID integer foreign key references. What is the table it is referring to? It is referring to employee table, and the column in the table is employee ID. So this is how you can define foreign key relationship. Let's see this executed successfully. Now let's try to insert. Let's try to do the first job. What is the first thing? No orphan records. That is the first thing it is going to do. So what I'm going to do here is, I'm going to insert into, I will take leaves. I'm trying to insert the data into leaves table without inserting into employee table, and let's see what's going to happen. Values, employee ID is 1, number of days he has taken is, let's say, 2 days, and the employee ID who has taken that leaves is 1. So I'm going to execute this part. So if I execute this, it is throwing an error saying that the insert statement conflict with the foreign key relationship in so-and-so database, and it is saying that I cannot insert the record. Why? Because this one will become orphan if I take this record. So this one fails. So what I have to do here is, first I have to insert into EMP table. Values are, let me take employee ID 1 and the name is Rupesh. And if you see, I inserted one record into the master table, that is parent table here, employee, and now I'm executing the same record here. Now this inserted successfully. Why? Because the master ID, this ID, whatever I'm using as part of the column employee ID in leaves table, which is referring to the employee ID of the master table, that is EMP table, is having the same ID. So now what I'm going to do here is I'm going to insert record 2, ID 2. ID 2 is not available, so it is going to throw error. So ID 2 I can insert only when I have the ID 2 in the master table, that is employee table here. Now I'm inserting 2 with the name Lokesh, and after that I'm going to insert this record. Let me execute this and see what's going to happen. So now both the records inserted successfully. So this is how the foreign key will make sure that no orphan records will be exist. Now let's select the data and see what is available. Select star from employee is one table and the other one is leaves. So let me take the other table, it's going to other one. Okay, if you see I have employee ID 1 and no employee ID will be present here, which is not available in the parent table employee ID column. So that is nothing but no orphan records will be available in the transaction table or child table, that is leaves table in our case. So now we have tested the first part. Now let's try to test the second one, that is deleting. Delete from employee where EMP ID is equal to 1. What I'm going to do here is I'm trying to delete the record. You can see I'm trying to delete this record where employee ID is equal to 1, but that ID is used in the transaction table. Let's see how it is going to react when I try to delete a record which is having a child record. So if I execute it, the delete statement conflicted with the reference constraint, that is foreign key reference constraint, and until I delete the child records, it is not gonna accept. So if I try this one fails. So what I have to do first? Delete from leaves. If I want to delete it, if that is my job that I have to do, then I have to delete it from transaction table. Delete from leaves where EMP ID is equal to 1. This should run first and then this should be executed. So let's see. First the child record be deleted. Yes, it is deleted. This is the one which deleted the child record. This is the output of that, and then the parent record. So this is how you can delete only delete any record in the parent table if and only if there is no child records in the transaction table. This case will apply only when you set the foreign key relationship. So, and one more important thing to remember is whenever you are giving reference to the foreign key, reference using foreign key relationship here, as I shown you here, as you are seeing here, I am referring this employee ID to employee underscore ID in the employee table using foreign key relationship. So in that case, you have to make sure that column that is being referred here, this is the column that is being referred, should be defined as primary key. So this is a mandatory point. Always you have to define the reference table, reference column as for primary key relation, primary key constraint. So this is about foreign key, different things that you can do, different kinds of condition checks that you can apply by defining foreign key. So you cannot delete any record, that is one step, which will lead to orphan records. And the second thing, you cannot insert in the child table, which will lead to orphan records. So it will make sure that no orphan records. That is very good sign of, very good way of maintaining the data. If there is orphan records, let's say, let's take a couple of examples. The first example, let's take the organization structure. If I say there is an employee ID 1 who has taken, who is drawing whom we are depositing 10,000 as salary every month. Okay. And if you ask me who is that one, and if I say I don't know who is that one, if there is any employee uh, who is taking leaves continuously, and if you don't have that guy's information, yeah, better take this example. Um, if I say I have an employee who is taking leaves continuously, and I don't know that employee who is, and that employee does not exist, that is not a valid scenario, right? And if anyone says that soap is fantastic, the sales is $50 million per month, and if anyone asks what is that soap, I don't know, that soap doesn't exist. So these are called as orphan records. So this foreign key relationship will maintain data integrity by by eliminating these orphan records in your database. The next concept we are going to discuss here is group by. So by is very important whenever you want to see aggregated data. Let's say you have data like this. Okay. Employee ID 1, 2, 3 and leaves 2, 3, 4, 5 and 5 leaves are taken, and number of days I need to have. Let me take a better example than this to demonstrate the group by. I have a table where in which I have product ID. So let me delete this first. So I have product ID and product name, and let's say these two. I don't want more. Let me change these two. And the product ID is 1, product name is Little Soap. Product 2 is Chintal. Product 3, let's say Dove. I have these 3 soaps, and in my transaction or child table, what I'm maintaining here is record ID and product ID and sales. Okay, so whenever and also customer ID. People maintain customer IDs too. Let's say I went to the shop and I bought a soap called Little Soap, and the sales is 25 rupees, and my customer ID is something. Let's say Rupesh is the customer who has bought that soap. And again, I went into the same market, same store, and I bought another Little Soap. The cost is 25. Again, the same customer. Now, a new customer has come who has taken the Chintal soap. The cost is 25. This guy name is Vinay, let's say. And other guy bought Chintal soap. The cost is 37 rupees per piece, and the customer name is Venki. And this is the fifth record, fifth transaction in the shop. The product ID is 3 and the cost is 45 rupees, and the customer name is Manoj, let's say. So if you see, if I ask you what is the sales of the Little Soap, what you are going to do? You will come here, you will take this ID, the product ID is 1, sorry, and you will come and join with this, you will compare, okay, how many products are there, how many records are there with the product ID 1, these 3, and what you are going to do is you will add these 3 and say that the sales is 75 rupees. And if I ask you what is the sales of Chintal, so you will take the ID, you will come to this child table, you will take this ID 2, how many IDs, how many records are there with the product ID 2, there is only 1, so you will come and say the sales is 37 rupees. In the same way, if I ask for Dove, You will come here and you will check, and there is only one record, so you will tell the sales is 45 records, 45 bucks. So what you are doing is you are aggregating this data. If you have more than one record, what you are doing, you are aggregating the data. And you can say that I have only a couple of records here. What the case if you have data like this? The record ID is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Let's say you have 25 records or some 25 million records. So what you have to do, you have to aggregate the data. You have to aggregate. First you have to get what are all the products that are with the ID 1 and then aggregate it. 25 plus 25 plus 25 plus and so on. So these kind of aggregation jobs or this kind of groupings will be done using group by statements. Let's discuss a lot. First let me create a couple of tables which will be useful to demonstrate the group statements. So already we have a couple of tables. Let me show you those two. Select star from employee. This guy has 5 employees, and select star from leave details. This guy has number of leaves taken of each for each employee ID. Here you can see. Now how to join these two tables? Select star from employee table, inner join leave detail table on, what is the condition? What is the common column here? Employee dot employee ID is equal to leave details dot employee ID. So this is the join part. If I join the data will be like this. Now let's say, observe this very carefully. My requirement is I want to get who is the employee. I don't want all the columns. I want only employee information, comma, number of days he has taken. So it is repeating, saying that Rupesh has taken 2 days, Rupesh has taken 3 days, Rupesh has taken 4 days, Rupesh has taken 4 days again, Lokesh has taken 2 days, Vinay has taken 3 days, and Vinay has taken 4 days. So this is simple. I have only 7 records information. So what I'm gonna do here is I'm gonna insert the same stuff, same data into the same table. You know how to do that. Insert into leave details, select star from leave details. That means it gets the data from the same table and pushes back into the same table. Let me execute it a couple of times so that I'll get hell of data. So it's executing. I have executed it 5 times, 7 times, 8, 9. Now I have more than 2 lakhs records. So what I'm gonna do here is I'm gonna execute the same query what I have executed earlier. Now see how many records you are getting. Rupesh 2, Rupesh 3, Rupesh 4, Rupesh 4, Lokesh 2, Vinay 3, Venki 4, and so on. It will be repeated for some 2 lakh records. I think it will be more than 2 lakhs. Let's see where it is gonna. So it has written 2,29,376 records. When I have data like this, when I have same employee taken leaves more than once, and if I want to get the aggregate data, in that case I will use group by. This group by will give you the aggregate data. Let me write a simple statement here. Select employee name, comma. Remember one point. Sorry. Let me do one thing. I've copied the same. What I'm doing here is I'm asking the server to group it by employee name. So that means select this required information, employee name and number of days from employee, inner join, leave details with the table leave details, it will join, and I'm asking it to give the group by information based on employee name. So what it will gonna do is it will take the distinct records. How many distinct records are there? I have only 4. One one is Rupesh, another one is Lokesh, another one is Vinay, and then last one is Venki. So it will take the distinct records based on this employee, and then it will give the group by statements. And remember one important point here whenever you are writing group by statement, that is this column, the column which is available in the group by is fine, and if any column is present in the select list, that is here, any column is present in the select list which is not present in the group by part, then that should be an aggregated column, either sum or average or first or last, something like this. It should be aggregated column. So I'm giving alias of it. So now the query has become, give me the number of days, total number of days, sum of number of days group by employee name. The output will be very interesting. You can see Lokesh has taken 65,536 days leave, and Rupesh has taken 4,25 days 984 days leave, and Venki has taken 1,31 days and 31,072 days leave. So what it is doing, first job, it will take the distinct of the column whatever you specified in this group by statement. So I have only 4 distinct records. One is Rupesh, another one is Lokesh, another one is Venki, and the last one is Vinay. And then it will apply the aggregate function whatever you specify here. You can simply ignore it. It is not mandatory that you have to specify the other column which is having aggregate function. You just remove it and execute what it is gonna retrieve. It is gonna retrieve the distinct part. Okay. It is not mandatory that you have to go for the aggregate column. So whenever you are grouping by, how you will see an employee wise number of leaves taken, or a student wise marks in all the subjects, or a product wise sales. So the requirement will be like this. So whenever you have such a requirement and whenever you are using group by statement, then make sure that you have a proper select list and proper columns in the group by. Now what I'm going to do here is, with the employee name, I'm also adding city. I don't know whether I have that column available there or not, and I'm adding the city in group by. So now I have added one more column into the group by, that is employee name and city into the group by. And if I don't give the city here and if I give only employee name there, it will say, stupid, you have missed one city. If you can see the error message clearly, column employee city is invalid in the select. That means here it is invalid because it is not contained in either an aggregate function or the group by class. If I have any column here, that should be either in the group by class or it should be aggregate column like this. This is an aggregate column. Either one of these should be true. So what I'm going to do here is I'm going to make it in part of the group by statement. If I execute this, now it has taken employee wise, city wise, the number of days. So what it will do, it will add and it will give the sum of number of days that every employee has taken. So this is the advantage of group by statement. Generally it won't it won't order the data. So what people will do is people will follow the same. It will they will try to order in the same order, whatever we have in the select list. So this one will take care of order part. Or you can just want to order by city, you can give that one too. Order by city, it has ordered the data, the result set in the ascending order of city. Now I explicitly specified the order should be in descending order. So this is how you can do that. So basically group by is used whenever you want to aggregate the data. You can use any aggregate function. It is not mandatory you have to go for sum. You can use, let's go for average. We'll discuss about all these aggregate functions. So I'm giving an example. So this is the average. Average means the total divided by number of rows. So total divided by number of rows will give the exact average value. So you can see it clearly here. And the next thing, you can go for first also. Oops, first will not come here. Let's say count. It will give number of rows that are present for each guy. These three guys are getting same number of rows. Why? Because these three guys have same record only once, and I inserted duplicate. I have made it duplicates. This guy has 3 times of this, or 3 times or 4 times of this. So you can see the same here. So this one will give count of rows. We will discuss about these aggregate functions, the functions we have that are available for us to use in SQL Server later. Try to understand the concept group by. The two important things you have to keep in mind whenever you are working on group by is, the first thing, all the columns that are in the select statement except aggregated column. Let's say this is the aggregated column here, count of number of days. So all these things should be part of group by. And group by will be defined after where class. If you have any where class where employee underscore ID is equal to 1. Okay. If I have where class, this should be defined after where class. So that is one important point. And the third thing, if you have any column that is not specified in the group by, but it is in the select statement, select list, then that should be aggregate column, either count or average or sum or something like that. You have to make sure that the columns that are not available in the group by are aggregate columns. Now let me go to the same query back again. I don't want to order this data. So this is the information I have. So people will ask, what is the difference between where class and having class? This is very important to know about having class. And this is very important in your question. What is the difference between where class and having class? Let me write one example here. So this is a group by statement. Before group by, I'm having a where condition where number of days is equal to 2. Okay, what it is gonna return? First, this guy will filter all the records where number of days is equal to 2, and then it applies the group by statement, right? There is only 2 guys who applied leaves number of days is equal to 2. That is, one is location and one is Rupesh, and it filtered that information and then it applied the group by part. So let me demonstrate the same query by splitting it into 2. So first, what will happen? It will execute this part. So first it will execute the where condition. Okay, these are all the guys who are with number of days is equal to 2, and then it will apply the group by part on top of it. So then this statement will be executed. So this is how the where condition works. Where condition will be used to filter before the group by part is executed. So the group by part will not be executed by the time the where condition applies. Now let's see what will happen if I use having. Having is similar to where class. Having is also used to filter the data, but having is used after group by statement, and this having, what it will do is it will filter. It is used to filter the data of the aggregated data. Let's say an example, having sum of number of days, the one what I have given here, you can see this part. Okay, sum of number of days greater than 65,536. So I'm asking the server, get all the leaves details, join with the employee table, and then group by employee name and city. And once it is grouped, then try to find out and pull the records where sum of number of days is greater than 65536. Let me execute this. And you can see I got only 3 records. Why? Because one record is this much. I have not given equal to, that's why it is not coming in the result set. So the major differences, the where condition will be applied before group by, whereas having condition is applied after group by. And where condition filters the data and then group by will be applied, whereas having condition first group by will be applied and then you can have the condition check of the aggregated data. I cannot achieve this requirement. I cannot achieve this part using where. Why? Because what I have to filter here. I cannot give anything like which filters this information, where number of leaves is equal to so and so. Okay. Well, let me tell you a classic example where this having is useful. Let's say in a class, the student, the teacher is evaluating who belongs to grade A and who belongs to grade B, grade C, and grade D. So for deciding grade A, the requirement is the student marks average should be greater than 80. In that case, I cannot use where condition. Like select star from students where marks greater than 80%. I cannot get that. So for doing the same, first I have to find out, I have to apply the group by and find out the average of the marks of 6 subjects. If the average gets 80%, then having average of marks greater than 80. If I give like that, in that case, I can get the grades. I can easily assign the grades to the students. So this is about having class and the group by class. Very, very important one in real time. So if I want to tell, if you want me to tell in short, the where condition will be applied on the data directly, whereas the having condition will be applied on the aggregated data. This is the aggregated data. If you execute this part, in the output, you can see one column is aggregated column here. That is with the help of sum function. So this having condition will be applied on the aggregated data. That is the advantage of having, and that is the difference between having and the where classes. So this is about group by statements and foreign key relationships. Now let's see one important object called views. Views are nothing but virtual tables. This table will not occupy any space. This table will not have any special space allotted for it. It is a virtual one. So then what is the use of this view? Let's see that one. First, before going for this uses on all, let's see how to create a view. Create view is the syntax we have to follow, and name of the view as keyword any select statement. Okay, this is how we can create a view. So let's try to create a view using a select statement. create view. The name is employee leaves is the name I have given for the view. As the select statement, what I am giving here is this one. Employee table joining with leaves details. Okay, this is the select statement I have given. You can see this is a valid select statement. If I execute this, it is returning me the data. Okay, so the view syntax is create view name as the select statement. Whatever may be the select statement, whatever the select statement you want to give, you can use it. And it is still executing. Let me stop it. And now I'm executing this part. So the command executed successfully. And if you go and see here, databases, under that MSBI, under views, you can see employee views, name, the view, whatever we have created. This is not a table. That's why it is not present under tables list. This is not a physical table. This is a virtual table. Virtual table means no special memory will be allocated for this. If it is a physical table, it will be available under this. Now, how to execute this view? Now you created it. What is the use of this view? And let's see. If I want to execute this part, okay, if I want to execute this part, I don't need to run this same select statement again and again and again. I can simply use select star from the view whatever I have created. So select star from employee leaves. This is the view I have created, and you can see it is retrieving, it is going in and getting the select statement that is present inside and executing the same. So this is the advantage of view. One of the advantages of view is you don't need to write the complex select statement and send it again and again and again. But create a view for the select statement and make and call that view name in the select. So this is one of the advantage. And the next thing is this employee leaves is acting as a table now. This is acting as a virtual table, and you don't know from which table this column is pulled, and you don't know from which table this city is coming, and you don't know from which table this number of dates is coming. So that means you are providing security to the data. Which table, which column. You are not providing that information to third person or the person who is working on it. So what you are providing is, if a person asks you, I want employee name, city and number of days, create a view and give it to him. Let him say select the views. That's it. Okay. This is how the view can be created and view can be selected. View is nothing but a virtual table, and what all you can give in the view definition. This is called view definition. What all you can give? You can give anything, any select statement, any valid select statement. If you think that is a valid and if it is returning some data, then you can give that. Now let's see how to alter the view. This is returning some 2 lakh records. I don't want all the 2 lakh records. I want to alter it. So in that case, you have to do alter view name. Simply give top 100. Top 100, what it will do? It is going to get only top 100 records. So what I need to change is just change the create keyword to alter keyword and change the select statement. Now I alter the view, and if I execute the same, select star from employee leaves, you can see it is pulling only 100 records. Here you can see the rows as 100. So how to alter? It is simple as change the create to alter, and whatever the select statement modifications you want to do, you just do it. That's it. I mean, you can simply create the view and you can use it in select statement and you can alter it. Yeah, this is fine. You are saying that, I mean, I said like you can simply change the create statement to alter statement by changing the create keyword to alter and changing the select statement. How I will get this view definition? Now if I delete everything, I want to get the view definition, right, to alter it. How I will get that? You can get the view definition in 2 ways. Here, right click, script view as, create to new window or file. What it will do is it will give you the view definition, or you can use sp underscore help text and provide the view name. So if I execute this, it will give you the view definition, copy it, paste it and modify it. Simple. I'm altering it. Instead of 1000, I want 100, I want 1000. So I modified it now. If I execute this view statement, it will return you 1000 records. This is as simple as this, creating the view and altering the view and getting the view definition, whatever the view definition is already present in the database, and all the different things so you can do with the views. Next thing, how to drop a view. Drop view and name of the view. So let's try to drop the same view what we have created. Drop view, employee leaves. So the view is dropped. That means the virtual table is dropped. Now if I try to select this, it will say, stupid, there is no such table or view available in the database. No such object available in the database. So that is dropped. So this is how you can create a view, you can alter a view, you can get the definition of the view by using sp underscore help text stored browser, and you can drop the view. The advantages of view, always there are, you have to highlight this point. View is a virtual table and it won't occupy memory. The next point, it will hide the functionality. It won't tell you what all the tables used and from which column is from which table. And you can mask the columns. Let's say this is your view and these are the columns you are pulling. It should be create, right? There is no such view available now. So you can mask it. That means as you are giving a new column name. employee name. And this one I'm giving as number of days. So if I execute this view, and now if I select the same, you will get new column names, employee name, city and number of days. No one knows what is the actual column name. That is one advantage. And the third one is, let's say you have 15 tables joined in one select statement. That one will become a pretty big. Believe in real time the queries, the select statements will be like 5 pages or 10 pages. Why you have to send all the 5-page query every time to execute? Instead of that, you can create a view. That one will reduce the bandwidth you are you're utilizing for sending such a big queries. Okay, so these are all the different advantages of using views, and the major one is it is not going to occupy, it is a virtual one and it is not going to occupy any special memory on the database. So that's it for today, and tomorrow we have lot of functions to discuss, like aggregate functions, text functions, numeric functions, date functions. So we're going to cover all the functions in the next session. Thank you.